Today we are going to start numerical of work and energy theorem and some basic concept of work. Okay. So write first question. Write down. Let me increase the text size. Write down.
Okay.
Question number 1. A particle of mass 2 kg starts from rest along x-axis. Okay. And subjected to a sidely you should solve question. Okay. I have shared a question bank for you. Okay.
Okay, sir.
Subjected to a force as shown in diagram, or you can refer any book. I will say like you can follow DC Pandey or SL Arora. Okay, reference book. Find
Okay.
final speed. Okay, I will draw the diagram. You just draw the diagram.
Okay.
Question, have you written question?
Yes, sir.
Draw the diagram. This is force versus displacement graph. Okay,
Okay.
6 here, 0 to 2 at 2 maximum force. Straight line. Okay, it is straight line like this, then like
Okay.
this, up to this. Okay, solves. Force versus displacement graph.
Okay.
To ask me like what is this? This is 20 minus 20. On x-axis displacement, okay. On y-axis force. So in this question, did I give you direct value of force? No, no. What they are saying, a particle of mass
No,
2
sir.
kg start from rest means initial velocity is 0. Okay. So initial velocity is 0,
Okay.
but there is no information what is the amount of force. This force is variable. Nothing is given. Here we are applying a particle of mass that is 2 kg start from rest is moving along x-axis. Then we are applying a force as shown in diagram. Okay, and this is the displacement in meter.
Okay.
Then obviously, like already I have explained, like the area under the curve will give the work, total work. A1, this is A2. Force displacement graph is given, always find the area. Total area will give the work. Area above x-axis you should take positive and below negative. Okay. Now this is what?
Okay, sir.
A1. Because displacement is a vector quantity. Force is also vector quantity. Should take care. Positive work done, negative work. So this is positive work done, this is negative below. So A1 will be what? Half. Base is 4. Height is 20. Clear? Minus
Okay.
half. Base is 220. So it will be how much? 40 minus 20, it is 20. Total work is how much total work by the force?
20.
3 joule. Clear?
So 20 joule.
So what is work
Okay.
energy theorem? Work done by all the force is equal to the change in kinetic energy. So how much work? Total work? 20 joule.
20 joule.
Then half final kinetic energy. Initial rest. So initial is 0. Mass is 2 kg. So V square will be what? under root 20. B will be under 20
Sir,
now. Mass is 2 cancel now.
yes, sir.
Root 5 meter per second. Okay. Is it clear?
Two, yes, sir, got you.
Is it clear to you?
Yes, sir.
Any doubt? Shall I
Yes, sir,
ask one
clear,
more
sir.
question?
No, sir.
Okay. Write one more question.
Yes, sir.
Write a question. Write a question. A particle of mass m is released from rest from point A on a rough surface where rough surface
Okay. Yes, sir.
frictional whose frictional force is very good. This particle again comes to rest at point B. I will tell. Okay. Then find the
Okay.
work done by friction. Whose friction is very good. Okay. Please note down. So I
Okay,
will
sir.
draw the graph also. Not graph, I think figure. Figure is like that. Like this. Solve this. Okay.
Okay, sir.
So our ball start from here. Okay. It's down because of friction comes to rest here. Okay. This point is B.
Okay.
This point is A. Okay.
Okay.
This is height h. Okay. From point A also rest. Okay.
Okay.
This also rest. Okay. This friction. So apply work energy theorem.
Okay, sir.
You please tell me how many forces are acting on this? One is gravity. Okay. How much work?
Okay.
Apply work energy theorem. Apply work energy theorem. So what is that? Work done by all the forces. All the forces means every forces. Like work done by gravity, work done by friction, work done by other forces like normal. Any other forces here? No. Is equal to change in kinetic. So there is no work by normal because see normal is perpendicular. Displacement is like this. Okay. 90 degree. So work
Okay,
done by
sir.
normal is 0. Okay.
Okay.
This is initial, this is final. Okay. A point is initial, B point is final. Clear? Work done by gravity. You
Okay,
please
sir.
tell me it is coming from A to B. From A to B, how much work is done by
Yes, sir.
gravity? Force, mg. How much displacement? The
Yeah.
direction
G
of
H H, sir.
mgh. Okay. Is it so?
Yes.
Work done by friction.
Yes,
Because
sir.
I told the definition of work. Force multiply displacement in the direction of force. Work done by
Okay.
normal is 0. There is no change in kinetic energy. Rest. So final minus initial is 0. Okay. So work done by friction will be how much? It is minus and change. Okay. Is it clear to you?
Okay. Yes,
Any
sir.
doubt? Shall I
No,
ask, shall I
sir.
ask one more question?
Sir, 1 minute, sir. Sir, 1 minute,
Right.
sir.
Take
Sir,
time.
work done by friction is minus something. How, sir?
How it, how it is
Sir,
like when you take it like
work
right
done.
now. This is work energy theorem now. From the
Yes, sir.
energy conservation na entire gravitation energy is went to where? Friction. That's why it is at rest na. Entire potential energy. You can say work done by
Oh,
entire work done by gravity. Hey, first of all, this is I'm not sorry. I'm not like it is coming from the equation. It is coming from the like the numerical calculation. I'm not doing. Okay.
yes, sir.
Energy conservation will not be applicable. First of all, I'm telling. Here, kinetic energy final minus initial is
Okay.
0. Otherwise, there is no conservation of energy. Entire mgh went to where? Friction. That is why it is equal to minus mgh. There,
Okay, sir.
there is no
Yes.
change in that. So, can I ask one more question?
Yes, sir.
Right on the question. A particle of mass 2 kg is moving in a straight line such that s means displacement, okay? Or you can say such that
Okay.
distance magnitude of displacement, okay, is equal to
Okay, sir.
dq by 3. Find the work done by find the work done by all the forces between 0 and 3 seconds. 2 seconds. Solves. So
Okay.
did they mention force? Did they mention displacement? Nothing. But they are asking find the work done by all the forces. Clear? So basic concept you must remember. You must remember this. What is the concept? Work done by all the forces is equal to the change in kinetic energy. So you need to find this now. For finding this, you must find the change in kinetic energy. That is half m final velocity square minus initial. Or you can say final speed minus. Is it so? Okay. Your voice is not coming. Hello. Your voice is bit interrupting. So displacement is as is what? dq by 3. Clear? Now differentiate this with respect to t. Time. Differentiate Hello. Differentiate with respect to time. Yes, Dinesh. Am I audible? Hello. Hello. Okay. T square. Okay. So you got this. What is this?
Sir, sir, can you hear me, sir?
Yes, yes. Tell me.
Oh, sir, T
Ds by.
represents time, sir, in the question.
T is the time. Yes, yes. T is the time. So ds by dt you got t square, na? What is this? Speed expression in terms of t. Clear? So for finding the initial velocity, starting from 0 to 2 seconds. So for finding the initial velocity, you just put it t is equal to 0. You will get u is 0 meter per second. In the similar way, ds by dt will be at time 2 seconds. That is the final velocity. That is 2 square. That is, so what is the work done by all the forces? It will be half mass is 2 kg v square minus u square. So answer will be 16 joule. Clear? Hello? Hello, Dinesh? Am I audible? Hello?
Hello, sir.
Yes, yes.
Sir, network issue, sir. 1 minute, sir.
You just check your network. Okay, that's are okay.
Okay.
See, I'm saying what in this equation distance is given in the form of t. When you differentiate this, you will get an expression in terms of t.
Yes,
Clear?
sir.
Then
Yes,
just
sir.
put the value of t equal to 0, you will get initial velocity. Clear? When you put the t is equal to 2 seconds, you will get the final velocity or final speed. Its magnitude. Okay?
Okay, sir.
Speed, velocity magnitude is speed. Okay?
Okay, sir.
Any doubt?
No, sir.
It is easy question. So how much work? 16 joule. Can I give one more question? You just write, okay? First write down. Take your time.
Sir, can you hear me, sir?
Yes, yes. Tell me.
Okay.
Yeah, you just
Nothing,
tell me what
sir.
is your
I
doubt
changed
you
that
were
network.
asking. You were asking some doubt.
Sir, no, sir. That previously I asked what is the T, sir, in the question.
Okay. Now you understand?
Yes, sir.
Okay. Shall I ask next question or you have written?
Sir, written, sir.
Okay. Next question, very important. These questions are very important. Now you
Okay,
will
sir.
feel like work energy theorem. Are you feeling?
Sir, yes, sir. But it's kind of collapsing, sir. Confusing.
What? Hello?
Confusing, sir.
Ah,
Hello,
network
sir.
issue, na? Yes, yes, yes. Yes, yes, tell.
Uh,
Are you
Sir,
understanding?
this is confusing. Yes, sir. I can understand, sir, but confusing. Like,
Why? Actually, when you practice more, na, then only you have more clarity. Till now,
okay, sir.
are you solving numerical? First of all, tell me.
Sir,
Are you solving?
numerical I have done till third lesson, sir.
So please solve numerical, okay? Work energy theorem, you should
Like
solve
till
all the
motion in a
numerical. So Dinesh,
Okay, sir.
if you solve numerical, then you have good practice. I can solve in the class. I am solving this many numerical, but along with that, you should solve some more numerical. Then only you have good grasp. You have good command. These numericals are
Okay,
very
sir.
important, which I am solving in the class. You should practice many times. In first attempt, you can't understand every question because these are high level of question. Okay, these are not a normal question. The
Oh,
Archimedes
okay, sir.
theorem, everybody read, but nobody know how to apply. Okay, you are
Okay,
good
sir.
like you are learning this. Your frictional coefficient is no. Symbol is I will write symbol later. Find the work done by applied force. Find the work done by applied force. When we learn any new thing now, so in starting it will take time. You can't be a good.
Oh,
You can't be best. First, you should be good. Then better, than best. Yeah. So first time when you are in
okay, sir.
nursery, you are learning something. Then you get a good command. You know how to form a sentence. So always, whenever you are learning something new, you should be happy like you are learning something new. Okay.
Okay, sir.
So in this question, I will draw the diagram also. This is the curve on which this is a particle having mass m. Okay. This
Okay,
particle is slowly taken from A to B. A to B. And this is the length of this. And height is h. Okay. They're asking you just tell me, will it go automatically? No. You need to apply some force. That should be applied force.
yes.
Okay. So my
Oh, okay,
question
sir.
is, how much work is done by applied force? Now, did they give applied force how much? No. Did they provide any other information? No. Then we will use
No, sir.
work energy theorem. Apply. If you don't know how to solve any question, always apply work energy theorem. Apply WET. What is this?
Oh,
All the force. Take all the force. On this, who is doing work? Gravity is acting on this. Okay. Gravity,
okay, sir.
normal. Take all the force. Work done by gravity, work done by normal, work done by applied force. And they are saying rough surface. Rough surface means friction also. So Work-Energy theorem is work done by all the forces is equal to the change in kinetic energy. That is it. All the forces means all the work done by all the forces is equal to change in kinetic energy. And they have mentioned slowly, slowly. If this word, if you find anywhere slowly, it means there is no change in kinetic energy. You are taking this particle from A to B very, very slowly so that the kinetic energy change always zero. There is no much change in kinetic energy. Okay,
Okay, sir.
like this, very, very slowly. So there is always this particle looks like it is at rest. There is no change in kinetic energy. But if you are taking the particle like this, am I visible?
Yes, sir.
If you are taking like a particle like this, gradually, then you can't say there is no change in kinetic. Slowly, if you take
Okay,
any,
sir.
if you find this term, slowly taken from A to B, then always change in kinetic energy is zero. Okay,
Okay, sir.
this is concept. Okay, from these question you will learn. These are IT based question, not only NCRT. NCRT you will find very very easy question. Okay, but I think
Okay,
like
sir.
if you can understand IIT based thing, then I think there is nothing left. Okay, now work done by gravity, work done by normal. How much work is done by gravity? You please tell me how much on this gravity force
Sir,
is
yeah.
acting mg. Displacement how much from A to
H.
B? H. Very good. So mg is down, displacement is up. Here, so it will be
Yes, sir.
minus. Okay.
Okay, sir.
Okay. Now work done by
Okay,
friction. Friction will be now you can understand friction. Frictional coefficient is given. How much work is done by the friction? Friction is how much? Tell me,
Sir,
how much work is done by the friction? How to
sir,
find?
1 minute, sir.
Can you solve?
Sir,
Try.
1 minute, sir.
I will tell one question. Work done by friction. Directly you should write currently minus mu mgl. You write, I will tell, okay?
Okay.
One question I will tell how to find the work done by friction on this curve. Later I will tell, okay? So change in
Okay,
kinetic
sir.
energy is 0. Is it okay up to this?
Yes, sir.
Put all the values. Minus mgh. Work done by normal 0. Like this. Normal is like this. Displacement is like this, okay?
Okay, sir.
Work done by applied force we need to find. Plus work done by friction minus mu mg. Okay. So how much work done by applied force? Mu mgl plus mgh. Okay.
Okay, sir.
Is it okay now?
Okay, sir.
Next. This is the work done by applied force.
Okay, sir.
If you want to solve one question like work done by friction, how we find? Write one question. In this question, write on the question. Write on the question. Write on a particle of mass. A particle of mass m is taken from. You want to be in JEE line, na?
Yes, sir.
So I'm saying like such numerical, tough numerical, let us solve. Okay. If you can solve
Okay,
this
sir.
much, then it's no problem for you. See, always look tough. Then only you can do easy.
Okay, sir.
Slowly. By applying a certain force. Find work done. Find work done by first normal, second gravity, third friction force, okay, fourth
Okay, sir.
applied force.
Sir, normal will be 0, sir.
Yes. Normal mostly case is 0. Okay, I will draw the diagram also.
Okay.
Particle is moving like on this curve. This curve is having the height z, this is L, and it is going from A to B. Okay,
Okay.
particle is moving. This particle is moving from A to B. It is having the mass It is going from A to B. I have shown here actually it is here initially. Clear?
Okay.
Now see the here like in this question normal work done by normal is 0. That is no worry. Work done by gravity also minus mgh. Okay.
Okay, sir.
Force into displacement. Force mg down. Displacement is h. But angle is minus because force is down. Displacement is up 180-degree angle. Okay. Now main question
Okay,
is
sir.
how to find the work done by friction. See friction force displacement is varying here. If you take small, if you move this, for example, this block, this particle for a small displacement, like here to here, small displacement, ds. Okay, if you take a small element of
Okay,
this,
sir.
it will be straight line. ds will be straight line. Is it so?
Yes, sir.
ds. Total displacement is s. I just take a small element because work done by friction is variable here. It is not constant. Okay, rough surface.
Okay, sir.
This is I just take a small element. In this small element, how much work is done by friction? How much work is done by the friction? Friction force multiplied displacement is ds. F dot s into angle between them. Cos how much? Theta. Okay,
Okay, sir.
clear? This is theta. ds means this is x, dx, dy, this is dx.
Okay.
Okay,
Okay.
so from here to here, displacement, there is a certain angle between displacement and the force, that is theta, cos theta. So, but what is friction here? What is
Sir,
friction?
friction. Mm,
How much friction?
sir, um, sir,
What done by
one,
friction?
1 minute, sir.
Friction formula is
Mm. Sir, it is
C. Forgettable. Forgettable. I'm telling one more easy. One more easy. Again, I'm solving. You are confused with theta, no? That is different thing. Let us understand. Wait.
oh,
Like this. Okay.
okay, sir.
This is the displacement. Okay. Small displacement. Friction will be like this. Opposite.
Ah, yes,
Displacement
sir.
is like
Oppose.
this. So angle is 180. Like this you can do. Then you have no confusion. And our object is placed here. This particle which is moving from small displacement, it is here. Okay.
Okay.
Any doubt?
No, sir.
Now understand this. This particle is placed, if I zoom out, it is ds, particle is here. Okay. Mg will be down. This is theta, normal. Okay. It will be theta. This is also theta. Here. So it is mg
Yes.
cos theta. Okay.
Okay, sir.
Why am I taking the small displacement? Because here friction is variable. Whenever force is variable, always take a small element. So for a small displacement, how much work is done by friction? That is F ds cos 180. Is it now? This is the work done by friction for a small displacement. Okay. Is it okay?
Okay, sir.
So it is F ds. Friction is minus mu n. N is, if you take this, n will be mg cos theta. So this particle is moving, it's not moving in the y direction, and will mg cos theta. Okay, this is the work done, small work done by friction.
Oh, okay,
If
sir.
you look at this, if this is ds, this is ds, can I take this is x, dx, this is dy, okay? This is small angle. Here I have taken theta. Actually, this is very, very small. You can take this is theta.
Okay.
Okay? I have written the theta, but you should understand, for your understanding, I have written theta, but actually this will be d theta. Why? Because this is ds. Okay, clear?
Okay, sir. Yes, sir.
So if you want to write, you can write here d theta. So work done by friction will be here also d theta. Just for your understanding, I have explained here, and will be mg cos theta like this. It will be mg cos d theta. Okay.
Okay, sir. Okay, sir.
So how much work is done by the friction? Minus mu mg cos d theta into ds. And if you find the cos d theta, it will be base by hypotenuse. Base is dx by ds. Okay, it's cancelled.
Okay, sir.
So how much work is done by the friction?
Minus mu mg dx.
So you just integrate from where? You are integrating with respect to x. And x will vary from where to where? A point, B point.
To be okay.
This total